Well, hello, this is Jeremiah. I am putting together a DIY computer build series. This first video is an instruction on what a processor is. So what exactly is a processor? So that's the main building block of your CPU. It's a centralized brain that operates and processes instruction set. So each processor contains a control unit which manages your operation. It has an algorithmic logic unit which executes mathematical and logical operations. And it also has a set of registers which provides temporary storage of information, source and destination of instructions. These three combinations allow the processor to execute programs. So, a brief overview of modern processors. So first I'm going to talk about the ARM processor, or known as Advanced RISC Machines. So this processor is built on a reduced instruction set computing. It usually has built-in RAM, video processing. You'll typically see this in tablets, cell phones, displays, computers like your Apple M1, mini computers like your Raspberry Pi, and it's also present in gaming consoles like your Nintendo Switch. So there's a company called ARM Holding, and they own all the patents to the ARM processor architecture. They license out the ability to build the chips and design these chips to other manufacturers. So the thing about ARM Holding is they actually do not produce any processors themselves. So when we say an ARM processor, we're talking about a system on a chip. So this contains multiple functionalities within one CPU. And these are typically hard soldered onto a printed wiring board. So because of these reasons, it is unfeasible to upgrade these ARM processors with new hardware, with the exception of limiting circumstances. The second type of processor that we have is what is called a microcontroller. And microcontrollers typically can run on either a complex or reduced instruction set. So when you look at your typical cars, robotics, drones, RC cars, any manufacturing, heavy-duty construction machinery, dams, etc., these primarily operate on a microcontroller. So the intent of a microcontroller is to take real-world inputs from a sensing device or technologies and perform actions based upon those inputs. A good example of this is if you had an RC car and you decided to push the button forward and it moves forward on its own. So that's one simple example. So the thing with microcontrollers, they typically do not perform an advanced graphics display. So let's take an example of a printer. So you have your home printer. It has a display that could be ran by a microcontroller, but nothing more advanced than that. If you see something on a computer screen with heavy graphics, usually it'll be an ARM processor or a different type of processor. There's another third one that's not often mentioned that is a microprocessor, and that is a field programmable gate array, or FPGA. So with this, it's a set of transistors array which allows the architect to design exactly how those chips function. So a lot of the times you can actually build in processors in an FPGA. So when we're actually talking about building a PC, we're talking about an X86 processor. So this X86 processor uses a complex instruction set. So nowadays these are typically built with 64 bits They used to be built with 32 and 16. So what does a 64-bit mean? So that's 2 to the 64th power, or 80 quadrillion number that it can represent. So currently the only manufacturer of the X86 processors are AMD and Intel. Those two companies are the only ones that hold and manufacture the X86 architecture chip. So whenever you purchase a PC that runs on the X86, it's either going to be AMD or Intel. So Intel manufactures their own chips as well as outsource their own chips to Taiwan Semiconductor Manufacturing Co. So they use a 5 nanometer technology at TSMC. So AMD also outsources their chip manufacturing to either Taiwan or Samsung. So when I say a 5 nanometer process, and that's the typical size of the transistor, or we can refer to those as electronic switches. Alright, so this part I'm going to go through a typical data sheet or information that's given to you by the manufacturer of what's inside your CPU. So you're either going to have a brand, so that's either AMD or Intel. So you're going to have a processor type, which is going to call out desktop. You're going to have that series, you're going to have a name, and then you're going to have a volume. So first important thing you need to pay attention to is this CPU socket type. Now for this AMD Ryzen 7 7800X3D, it uses the AM5. So a socket set is what is on your printed wiring board or your motherboard that has a specific footprint that needs to fit in there. So currently the most recent footprint of this CPU socket type for AMD is AM5. So number of cores, this refers to the number of processors within there. So this processor has 8 individual core sets that can execute code simultaneously. It has listed 16 threads. What 16 threads means is you have 2 lanes of bus of instruction code that runs alongside the processor that is ready to execute code. So when you're going through and you execute one set of code, you already have another set of code right behind you because of this multi-threading per processor. So the operating frequency as shown here is listed at 4.2 gigahertz. What's this mean is that's the clock that the processor operates at. So every 4.2 gigahertz it performs a logical operation. So the maximum turbo frequency, and this is just what it can run up to. I'm sure it can run beyond what is listed, but this is the guaranteed minimum. So there's 3 different caches that are called out here. You have the L1 cache, L2 cache, and L3 cache, and they increase in size as you go along as well. So the L1 cache is right next to inside the processor and is the most easiest one to reach. So every single processor core inside this has a L1 cache. So there's also a L2 cache, and it's a little less easy to access than the L1 cache. And every single core has an L2 cache as well. And then you have an L3 cache. And that is shared memory across all of the processors that it can access. So the lower the number, the easier and quicker it is for your CPU to access that stored information. So little thing about this AMD Ryzen 7 7800X3D, you see the 3D. So that actually is referring to your cache. For this particular model, they actually store this in parallel above or below the CPU to make accessing this cache quicker. So this processor uses the 5 nanometer technology, 64-bit support. Yes, so I can't remember the last time I saw a processor that wasn't 64-bit for the X86, so that I don't anticipate that changing at all. So the memory types, so this CPU can actually handle the DDR5 5200 memory. So memory channels, it can handle 2. So when you get your board, this you'll either get one with 2 slots or one with 4 slots. If it's 4 slots, those are 2 sets of 2 in parallel, making 4 memory channels. So ECC memory, this is error code correcting memory. So if data and error is wrong, you might want to think about using that. Typically before AM5 socket, this wasn't actually offered on your CPU. So most processors come with an integrated graphics card. So this one comes with the AMD Radeon graphics, and it operates at 400 megahertz, and it has a graphic max dynamic frequency of 2200 megahertz. So this max dynamic frequency allows for short bursts of data processing at a higher end speed to process a lot of data all at once at a higher speed, but it's only for a limited amount of time. So this CPU supports the PCI Express of 3, 4, or 5. Typically, you won't have to worry about this because it'll be on your motherboard. And then thermal design power, that's the maximum power dissipated at a time. So cooling devices. So this processor, when you purchase this, it does not come with a cooling fan. They used to come with them. Now they're leaned away from that, and you don't really get a cooling device with your processor anymore, but it could. So operating system, it says on here Windows 11, but it's going to accept probably any Windows that you can install on there. So this is a walkthrough of the AMD Ryzen processor. Now let's take a look at the Intel. Alright, so this is an Intel processor. So it's a desktop. It's the i9 12th gen. So the name and model are listed. So this one uses the LGA 1700 socket. So this is also the most recent socket. One thing I give advice about when you order PCs, you might want to consider whether, if it's within your budget, to order the most recent socket set. So this will allow you to upgrade your CPU as time goes along. So for this particular processor, it has 16 cores. 8 of these are what are known as a power core, and 8 of these are what is known as efficiency core. So when you go down and break down to the transistor logic of a CPU processor, you can rearrange and lay out those gates to different configurations to either make your processor more efficient, or you can make it quicker. So there's designs that they go through to either optimize on either power or efficiency. So there's plus and minuses for that. So obviously your power cores consume more power, but they can process more information in a lesser amount of time. So your energy efficient core, so you lose speed and you use a reduced amount of power. So if you're walking through and operating Word, you don't need a power core. The energy efficient cores enough for that. So this has an odd amount of threads. So I take it, the power core has 16 threads and the energy efficient core only has 8 threads because it doesn't need it. So it has a max turbo frequency of up to 5.2 gigahertz. So you have different operating frequency between your P core and your E core. So it has an L2 cache, an L3 cache. So this manufacturing technology is on the Intel 7. So the Intel 7 manufacturing tech is a 10 nanometer mode. So that's twice the size of Taiwan tech. So the memory, this processor can actually support either DDR4 or DDR5 at the listed speeds. So when you buy your motherboard, you're not going to be able to choose between either DDR4 or DDR5. Your restrictions on which one you'll be able to use will be based upon your motherboard, because every single DDR slot is different, so that way you cannot fit them. It has the same amount of memory channels. It supports ECC memory. It has a max memory bandwidth of 76.8 gigabytes. So it also has an integrated graphics as well. It can support PCI Express 4, 3, or 5. So the max number of PCI Express lanes you can have on this processor is 20. And then it also consumes up to a maximum amount of 241 power. And then this also does not get a cooling device. So it lists the operating system as Windows 11. It could operate any other X86 operating system. So just to go over a quick recap. So when you're selecting the processor, you need to pay attention to what socket type you're getting. Usually you'll want to get the most latest sockets type if it fits within your budget. As you go along, it can easily be upgraded with new processors that also fit in that same socket. You can also pay attention to the operating frequency. Typically, the faster the operating frequency, the quicker your data gets calculated. Number of cores also is something that you pay attention to. Usually the more cores the better. Sometimes you won't need, or most of the time you don't use all the core. Depends on your operation that you're using it. Gaming typically use quite a few. You get to high-end operations like engineers and so forth where you really need a lot of CPU processing. You can use up to 8 or more. So pay attention to the RAM support. So when you get your RAM, you need to make sure that it's compatible with that CPU socket. So pay attention to max power draw. This is less that you have to pay attention to on the CPU. Typically your motherboard will tell you the amount of current draw or power that it draws from it. And so ultimately there's differences between the processors, the layout, and the particular design. So it's one to just look at the data or the specs of the processors, but I do strongly encourage you to look at CPU benchmarks to determine which one will fit your need. Because even though one might be faster, it doesn't mean it's going to be more efficient. So other things I would consider is when you go and purchase your CPU, typically you can get a better deal on a motherboard CPU combo than you can with just buying the CPU. When you buy these combos, typically they're bundled together to where they fit with one another, unless somebody did a bad job in marketing. So if you like this video, I appreciate it if you give it a thumbs up. If If you want to learn more, type down below in the comment section. I can ask you questions or answer your questions for you. And my next video in this series will be about motherboards. Have a good day.